the maximal sum of a rectangular subarray. Here is your same structured beginner-friendly content for maximum sum rectangular subarray, advanced level, 2D Kadane's algorithm introduction. In 1D arrays, we solve the maximum subarray problem using Kadane's algorithm. But in real-world problems, data often comes in 2D form, matrices. The advanced version of this problem is find the rectangular submatrix with the maximum sum. This is also known as maximum sum rectangle, 2D maximum subarray. This problem is important because it teaches extending 1D algorithms to 2D, optimizing nested loops, prefix sum ideas, advanced dynamic programming, problem statement. Given a 2D matrix, find the subrectangle, contiguous rows and columns with the maximum sum. Example matrix: 1, 2, -1, -3, 4, 5, 2, -1, 3. Output: maximum sum equals 12. Sub-rectangle: 2, -1, 4, 5, -1, 3. What does this mean? We need to find a rectangle inside the matrix such that rows are continuous, columns are continuous, sum of all elements is maximum. Core idea: 2D problem means convert into multiple 1D problems. Why not use brute force? Brute force approach. Try all rectangles, compute sum each time, complexity (on² times m²). This is too slow for large matrices. Optimal approach: 2D Kadane's algorithm. We reduce the 2D problem into a series of 1D Kadane problems. Core formula: 2D max sum means apply Kadane on compressed rows. 2D max sum means apply Kadane on compressed rows. Key idea: fix 2 rows, top, bottom. Then, collapse rows between them into a 1D array. Apply Kadane's algorithm. Visualization: select rows means compress columns, means apply 1D Kadane step-by-step algorithm. Step 1, fix top row. Step 2, move bottom row. Step 3, create temp array. Temp call equals sum of elements from top to bottom for each column. Step 4, apply Kadane on temp. Step 5, track maximum result. Example walkthrough. Matrix: 1, 2, -1, -3, 4, 5, 2, -1, 3. Fix top equals 0, bottom equals 0, temp equals 1, 2, -1. Kadane means max equals 3, bottom equals 1, temp equals -2, 6, 4. Kadane means max equals 10, bottom equals 2, temp equals 0, 5, 7. Kadane means max equals 12. Final answer: maximum sum equals 12. Java implementation: public class maxsum rectangle. Public static int maxsum rectangle int colon matrix. Int rows equals matrix length. Int cols equals matrix 0.length. Int max sum equals integer min value. For int top equals 0, top plus top, top plus plus. Int temp, new int calls. For int bottom equals top, bottom less than rows, bottom plus plus. Add current row to temp. For int call equals 0, call less than calls. Temp call plus equals matrix bottom call. Apply Kadane on temp array. Int current max equals Kadane temp. Max sum equals math max. Max sum current max. Return max sum. Public static int Kadane int error. Int current sum equals error 0. Int max sum equals error 0. 4. Int I equals 1. I less than r length. I plus plus. Current sum equals math max ri. Current sum plus ri. Max sum equals math max max sum. Return max sum. Public static void main string args. Int integer matrix is 1, 2, -1, -3, 4, 5, 2, -1, 3. System out.println max sum rectangle matrix. Output 12. Time complexity. Outer loops. Top row means O of n. Bottom row means O of n. Kadane per iteration. OM. Total complexity. O(n) squared times m, space complexity. Only temp array used. Why this works. Instead of checking all rectangles, we fix row boundaries, reduce problem to 1D, reuse Kadane's efficiency. Example concept. 2D means multiple 1D problems, one's efficient solution, real-world applications, image processing, find brightest region, financial data, best profit region in heat map, machine learning, feature heat map optimization. Example concept. Grid data means best sub-region detection advantages. Advantages include efficient compared to brute force, scalable solution, uses known 1D algorithm. Example concept. Kadane extension means powerful optimization. Limitations. Challenges include complex logic requires understanding 1D Kadane, harder to visualize. Example concept. Higher dimension means higher complexity. Common mistakes. Not resetting temp array properly. Incorrect Kadane implementation. Wrong row iteration. Example concept. Incorrect accumulation means wrong result. Concepts learned. Extending 1D Kadane to 2D. Matrix traversal optimization. Dynamic programming in grids. Reducing dimensions. Efficient submatrix processing. Simple definition. Maximum sum rectangular subarray. Find the rectangular region in a matrix that has the largest sum. Final summary. The maximum sum rectangle problem extends the 1D maximum subarray problem to 2D matrices. By fixing row boundaries and compressing columns, we reduce the problem to multiple 1D Kadane problems. This results in an efficient solution with O(n) squared times m complexity. Understanding this problem is essential for mastering advanced dynamic programming, matrix algorithms, and optimization techniques.